Hi everybody, in this video tutorial we are going to discuss about how to debug an application as a C++ C program in a Eclipse IDE, right? So you have to download a Eclipse IDE in which there is C and C++ plugin, or if you have already an Eclipse IDE you can also download the plugin and you can attach with it IDE, right? So now I will explain you how to create a new project. So you go to file and you give new, and then you have to give C++ project, right? So here matrix means I'll just give the name of the project. Name of the project is different from name of the class or a file, whatever we are going to create. After you give the name, you give finish, right? And then what we have to do is I'm going to copy this code because this is what I'm going to copy there. Now select the new project, right click there and say new, and then file, and here you say matrix.cpp because I'm going to have a C++ program. I'm giving the extension as cpp. If you want to do C program, then the file extension must be .c, right? After you do this, you can just compile this. Before we compile, actually it is better to have only one project to be open. So what we shall do is we can just see there are two projects open now. One is matrix, another one is matrix 1. Both are in open state. You can see that when it is like open, it is open state. You can see other projects like stack 1, stack 2 are all closed, whereas this is open. Now I am going to close this project, right? That is using right click on that project and give close project, because at a time it's better to close the project. Only one project can be open. That is better to work with, right? Now what we are going to do is we are having the matrix class. Now you go to project and you give this option build all. Okay, after you give build all, we can just say run matrix, run. Okay, so you'll see that in console you'll see different windows here. You can see different windows, that is problems, tasks, console and so on. Now we have to come to the console window. When the program is executing, the IDE will receive the input only through the console window. Now I am entering the dimension of the first matrix. I say that the first matrix is a 2 cross 2 matrix, and then I say elements in the matrix are 1, 2, 3, 4. Just assume like that, right? And then after this, it is waiting for the second matrix dimension. I say that is also 2 cross 2, and I enter the elements as 1, 1, 1, 1, 4 elements, right? The program performs the addition operation and prints the value as 2, 3, 4, 5. This is the resultant matrix. This is how we can execute. This is the button we will use for executing. This is the button that we will use for running the program. Now what we have to discuss is, actually we can debug. IDE makes us easy to debug the application. When you see the program, in this program what we have done is, you can see that we have included the header files, and then I have declared one error flag. I will say what is the purpose of the error flag when I go to that line. Before that, you see this is class matrix. When we see class matrix, we know that it has properties rows and columns, right? You have row, you have column, and then elements. We are going to dynamically allocate the memory for the elements. Already we have discussed in class how to dynamically allocate the memory for a two-dimensional array. So I just declare only a double pointer for that particular data member, right? I'm just saying int star ALE, and then you see this is the default constructor for which we don't pass any parameter, right? Next line contains the next line contains the parameterized constructor. This is the default constructor. This is the parameterized constructor. For parameterized constructor, we pass two integers. First value will say what value has to be assigned for row, and the second one will say what value should be assigned for columns, right? And then we have the copy constructor. This is the line where we declare the copy constructor, right? copy constructor is a parameterized constructor which take object of the class of the same class as parameter. So you can see here matrix is the class, it takes another matrix object as parameter, and then you can see this is the destructor. What is the difference between a constructor and destructor? Destructor will be preceded by this tilde symbol, and also that destructors will not take any parameters as constructors. We already know that constructors will not return anything. Similarly, destructors also will not return anything, whereas parameters will be passed for constructors, but for destructors we will not pass any parameters. And then next you can see the add function. Right, when you see the add function, we know that when we want to add two matrices, we require two matrices, isn't it? So since this is object-oriented programming, we will call this function through one of the object. So explicitly we will pass another object, and I want to pass it by reference, right? And you see the return type, when we add two matrices, we will get another one matrix as output. So the return type is the address of another one matrix. And then we have functions like get to get the input for the matrices, and then we have print function to print the values of the matrices. We have defined this print function as constant because this is not going to change the value of any of the data members. When we say member function is constant, we mean that it cannot modify any of the data members. It is having only a read-only access. It can read the values of data members, but it cannot modify the value. Obviously, a print function should not modify any of the data members. Then we come to the default constructor. In the default constructor, what we do is we initialize the row and column to be equal to 5, and then we allocate the memory, right? In this allocation, first of all, we are allocating the memory for the pointers. We already discussed, isn't it? So when we are having a two-dimensional array, we are going to view that as array of arrays, right? So I am creating an array of pointers to store addresses, right? This is the first step in allocating memory dynamically for a two-dimensional array. And here, what in the next line I am doing is I am going the element by element, and then I am allocating the memory for storing the elements. That is what is here, right? And next is the next is the parameterized constructor, where we pass two values for the constructor. R is the number of rows in the matrix, and C is the number of columns in the matrix. Here we say row equal to R, column equal to C. We assign the values whatever is passed by the user. And then what we are doing is we are allocating the memory as we did in the default constructor. And then copy constructor. Copy constructor is nothing but it is like a Xerox machine. So if I pass a matrix, then this copy constructor will exactly create a copy similar to that, right? So you see that it is saying row equal to m dot row, column equal to m dot column. And then when we are going to see the elements, a new memory will be allocated, and then elements will be copied one by one from the past object to the new object, right? It cannot just say ELE equal to m dot ELE. That is what is called shallow copying. The system by itself provides default copy constructor by default, but what it does is called as shallow copying. Okay, particularly copy constructor is important when we are dynamically allocating memory for the data members, right? So if I have a pointer, okay, for which I allocate the memory dynamically. If I'm not writing a copy constructor, if I'm passing that for a function, or if a function is going to return an object of the class, then the system automatically provides a default constructor where the values will be just copied. Okay, that is, if I have some array of elements, that the address alone will be copied. We know that each object and variable has a scope and a life, right? If the object from which the address is copied goes out of the scope, then the other object will have an address which is not still with the program. Okay, that will be called as dangling pointers. To avoid that only, we have to provide copy constructors whenever we are dynamically allocating memory for data members. If we are not allocating dynamic memory, it's fine. We can work with the default constructor, the default copy constructor provided by the system itself. but when we dynamically allocate the memory, it is mandatory to provide the copy constructor. So you just see here, we are allocating the memory newly for the element, and then we copy the contents one by one into it, right? We are having a for loop to copy the elements, and then this is the destructor, right? Whenever we use new operator to get the memory, we have to give it back to the system by using the delete operator, right? Similarly, in C also, whenever you are using malloc or calloc, it is must that you must also free the memory by using the free function, right? So you see here, first of all, we return the memory of the elements, okay? Whereas it will be opposite to the way how we did when we got the memory, right? When we were getting the memory, first we allocated the memory for storing the pointers. You can see here in star. In star means we are going to store address. We are creating an array where we are going to store address, right? Here you can see that first of all we are giving back the memory allocated for storing elements, and then we are giving back the memory allocated for storing addresses, right? That is in the reverse way. This is the add matrix, right? Here only we use the error flag. We initialize the error flag equal to 0, and then we check the dimension of the matrix. We know that two matrices can be added only if they are of same dimension, okay? So you just see here, if row, actually one of the object will come implicit, isn't it? Because when we call the add function, we will call through one of the object. For example, I will call like m1 dot add of m2, right? So m1 will come implicit and m2 will come explicit. So I am checking here whether number of rows is equal to, both of the number of rows are same. When I say row, it refers to row of the object that has come implicit, and when I say m dot row, it refers to the row of the object that has come explicit, row of the matrix that has come explicit. Similarly, I am checking whether columns of the number of columns of the implicit matrix is equal to the number of columns of the explicit matrix. If any one is not equal, so when I am using here a OR operator, if any one of the thing is not equal, then what I am going to do is I am just going to create a dummy matrix, right? And I am going to set the error flag as 1 to indicate that matrices cannot be added, right? Generally, it is not advisable to print in the member functions. We will only communicate to the main or function whichever calls these functions. That is the professional way of doing code. So we are just saying error flag equal to 1, and I am just returning the dummy matrix because we have set the return type as matrix, okay, address of matrix. The system will expect us to return a matrix, right? And then otherwise, if number of rows and number of columns of both the matrices are same, then what we are doing is we are performing addition, right? So the new elements will be in M3, right? The new elements will be in M3, and you can see here this is a to for loop, and since M3 is a pointer, we have to use this operator to access the number of rows and number of columns, right? And you can see here what I am doing here is I am just saying here M3 equal to, right, M3 equal to new matrix of M2. I mean that I am invoking the copy constructor, and I am creating exactly a copy similar to M2. M3 is now similar to M2. So number of rows will be same and number of columns will be same as that of M2, right? And then what we are doing is we are going through the elements one by one and then adding it. This is what we are doing in the add function. And then you can see this is the get function, right? In the get function, what we do is we get the number of rows and number of columns from the user. We will invoke this get function through one of the object of the matrix, so we don't pass anything explicit, right? And then you see that this is the loop which is controlling and getting the elements one by one. And print matrix, we are printing the elements one by one. You can see that here also we need not pass anything because print function also will be invoked through a matrix object, right? So that implicit object elements will get printed. Now this is the main. In the main, what we do is we create two objects, m1 and m2, and I am creating another one object pointed to another one object m3, where I am going to receive the address of the newly created matrix, right? So you can see that first of all I am getting the elements of m1 and then m2, and then we are calling add function. When we call add function, you can see that we say m1 dot add of m2, right? Here what happens is when we say like this, m1 goes implicit and m2 goes explicit. We saw that we have written like simply like row column, that will refer to the row and column of the object m1, whereas when we say this object has got us m2 there, okay, in the function. So when we say m2 dot row, m2 dot column, it refers to rows and columns of this particular object, right? And after calling the add function, what we do here is we check the error flag. If the error flag is equal to 0, we can understand that the matrices cannot be added, isn't it? If error flag is not equal to 0, so we check. If error flag is 0, then we are going to print the resultant matrix, that is in the m3, right? Address is stored in the m3, so we are using this operator to print, okay? That is dereference operator is used for printing the matrix. Otherwise we are printing that matrices cannot be added, and then we are saying delete m3. When we call delete m3, automatically the destructor will be called. This is the explanation. Now we will debug the program. I will explain you how to debug the program. So debug the program, first of all we have to set the breakpoint. For example, if I am going to set the breakpoint in this line, then bring the cursor, click here and bring the cursor here, right? If I want to click have breakpoint here, then bring it here, and then what we have to do is Control plus Alt plus B. You can either set the breakpoint using this. You can see that a bullet appears when we do that. That is Control plus Alt plus B. You can do like that to set the breakpoint. Otherwise, you can go to Run menu, and then you have an option called as Toggle breakpoint. You can also click this. Toggle breakpoint is used for toggling. That is, if already a breakpoint is set in this line, then it will be removed. If there is no breakpoint in that line, then it will be set. That is the purpose of toggle breakpoint, right? You can use that and you can set, or you can use Control plus Shift plus B for setting. That is also toggle. That is a shortcut key provided by the IDE for setting and removing the breakpoint. After you do this, what we should do is we must now click the debug. This is the bug. You can see bug icon. If you click this, then automatically debugging will be started. You can see that something like confirm perspective switch, that is from the normal perspective we are going to switch to the debug perspective. It will ask you for confirmation. You can say yes. As soon as you say yes, you will see that the program starts executing, and you can see that something like this, that is there is an arrow which can be seen. This arrow is only indicating the line of execution. Now currently this line, that is the first line of main is getting executed, so you can see a arrow operator there, right? And then you can also see that there are two things. This is called step into, right? Step into means when I want to see what happens in a function step by step, I will use this step into. And then next one is step out or step over, which means that I can just execute the function. I do not want to debug the function. I do not want to see step by step. I can use this step over function, right? So now we are in this line, and I want to see step by step. I think like that. So I press this step into, right? So first of all, the object M1 is created. We can see that the constructor is automatically invoked by the system, right? Whenever an object is created, the constructor is invoked, and since we have not passed anything, the default constructor is invoked. You can see that the arrow here and the green highlighted line, that is what is the line that is getting executed, which shows that constructor is getting executed, right? Now we will see, now we will execute step by step, right? So you can see that now I don't want to see. Those things are built-in functions. I don't want to see, so I'm giving step over, right? Right, you can also see the things here going on, that is what is the value of I and so on. If you click here, you will see what are all the elements. You can see that some address is stored here like 0x, right? The memory is getting allocated and the address of the first byte is stored there. that is 0x603010 is the address, right? If you see further, if you click here further, you can see what about the element. Okay, so you can see it is star alias in star, and further if you open and see, you will see what is the value that is stored here. Okay, initially it is all 0, right? And number of rows and number of columns are 5, because we have invoked default constructor. Default constructor initialize the number of rows and number of columns as 5. So you can see here after the execution, the number of rows and number of columns are 5, right? So you can step by step execute this, right? As soon as it is over, it is coming to the next line, right? In the next line, what we do is we are calling the get function, right? So it goes there, and now we can see, right, it is waiting for us to enter the input. It is getting the number of rows. You enter the value and press enter, and then enter the value and press enter. Now it has read the number of rows and number of columns. Now it is waiting for you to respond in this particular line. Now you can say step over, because I don't want to see what is happening inside. Then I am getting the elements one by one. You can see that it is waiting for you to enter the first element, right? And then you can also see the for loop. Inner for loop will get executed first, and then only it will go to the outer for loop. Whereas I have entered the dimension as 2 cross 2. Now I have entered the first element, that is the first element in the first row. Now it is waiting for you to enter the second element in the first row, right? I just say 1 2, right? Now it's waiting for me to enter the third element in the row, right? So I may say as 3, and then okay, so it is waiting for you to enter 4, right? And then it is over. The first matrix is got, right? Now it go back, and now it is waiting for you to get the elements in the second matrix. I have pressed F6, that is step over. So you can enter one by one. Just enter some values, right? Now it is waiting in the next line of the main program, that is add, right? Now I want to see how add works, so I am pressing the F5, right? F5. You can see that the add matrix function is called, right? And then now it is checking whether number of rows. You can also see here, right? This actually will contain the address of the first matrix, that is M1, right? We can see here what is really, and then star really, right? You can see here there is, right, the elements are stored one by one, and then number of rows and number of columns are given as 2. Similarly, another one object is there, M2. For M2 also you can see some other address is given, and then we are having rows to be 2 and columns to be 2, right? And another one is M3, right? For M3 we have to assign the address, right? So you can just see here, I will give like this, right? Now we are creating the object. A new address is assigned, so you can see that the address of M3 now gets changed. Previously it was a garbage value, isn't it? Now you can see that the address of the M3 is according to the memory allocated, the address gets changed, right? And then what we do is we go through the elements one by one, and then we add the elements, right? So you can see that the value of I and j, you can keep track here, the value of I and j gets changed for each step, right? You can understand by looking at it. After finishing add, I am just checking whether the error flag is set or not. If the error flag is set, then only it's not set, then only I'm going to print. So you can see that error flag is not set, so it's calling the print function, right? So the control goes to the print function, and we print the values one by one. You can see in the console that it is getting printed one by one, right? So right, and then we have finished execution, right? Delete, right? Now it has come to delete. You can see that when we invoke the delete for a particular object, automatically the destructor is called, right? Constructor is called when an object is created, and destructor is called when an object is destroyed, right? Destroyed means if you consider our case, our program, we have two types of objects here. One is M1 and M2 are static objects, okay, for which memory allocation will be done in the beginning of the execution of the program, and M3 is a dynamic object. We just had a pointer and we allocated the memory in the add function, isn't it? And also we are calling the delete for M3, but whereas for M1 and M2 we don't do anything. Automatically destructor will be called for M1 and M2 when those objects goes out of scope. But for M3, since it's a dynamic object, destructor will be called when we are using delete for that particular object. So we had this line delete M3, so the control is here, that is it has entered destructor, right? Now I am just giving this, right? Now it is deleted, right? See that again. Now if we say step into again the destructor will be called for the static objects, right? For M1 and M2 it will be called. That is what we can see, right? This is the demo for debugging a code in C++, right, using the Eclipse IDE. After that the window will be like this. So go back, what we have to do is we have to say window open perspective C bar C++. If you say, then the window will be in normal mode where we can type and see the code. Now I also say that you can also debug and see. You pass a object by value. For example, I will change this matrix. Here I passed by reference. I will just change this to be value, right? Now what I will do is I will change the breakpoint from this line to this line. That is, I want to see only what happens when and is called. I do not want to debug the program from the beginning. Then I am removing the breakpoint from this point. How will I remove is? Control plus shift plus B I will remove. So as soon as the breakpoint is removed, you can see that bullet in that line is gone. Now I want to set the breakpoint here. So shift plus control plus B, right? Now the breakpoint is set here, and I want to debug the code. So you press this, right? Okay, I don't know why it is showing error. We'll just check it. I'll check 1 minute. Project build of that is, I have to change the declaration of the function also. So that is the error. When I change the definition of the function, then I have to change the declaration also. That was the error. Now the error is gone, right? Now I can press the debug option. Okay, so it is asking for confirmation. I'm just saying yes, right? So you can see that it is waiting here, but I can enter one by one. Now I am entering 2 cross 2 matrix, 1 1 1 1 4 elements, 2 cross 2. I am entering the elements as 2 2 2 2, right? Now over. Now I am in add function. Now I want to see what happens here, isn't it? So I am going to press step into, right? You can see that when I press step into, automatically it enters copy constructor. You can see that we have not invoked the copy constructor anywhere in the add function, but it is automatically invoked because when we pass an object for a function by value, automatically the copy constructor will get invoked. Similarly, when we are going to return an object from a function, okay, and it is by value, means automatically the copy constructor will be invoked, right? Now we are just skipping the steps because we know that step by step it will copy the values, right? Now it goes to the next line because I have pressed step over, it has come. So you can understand that when we pass the object for add by value, the copy constructor is invoked. This is general. Okay, whenever we pass a object by value for a function, copy constructor of that particular class will be invoked. Similarly, when you return a object by value also, copy constructor will be invoked. Okay, this is what I wanted to say about debugging. So I want to go back to the original perspective. So you go to window, open perspective, and you press C bar C++, you will come back, right? So thank you.